Hello everyone. Welcome back to the show. It is Monday, December 8th, 2025. I'm your host, ichino-ani. I hope you're all having a wonderful start to your week. Today, I have a really fascinating trending article to share with you all. It is about the hidden secrets inside artificial intelligence. The title of the paper is Universal Subspace, and the title is Chats Not Choshikwaku. This is a really big discovery in the world of computer science, specifically in machine learning. So, let me explain what is going on here like I would in a classroom. Imagine you have a class of 500 students. They are all studying different subjects. One is studying history, one is studying math, and another is learning how to paint. Usually, we think their brains work in totally different ways, right? But what if I told you that deep down, the way they organize information is actually almost exactly the same? That is the problem this paper is trying to solve. For a long time, scientists thought that when we trained different AI models, they all learn in unique, messy ways. We thought that a model trained to recognize cats was totally different from a model trained to write poetry. This makes things difficult. It means every time we run a new AI, we have to build it from scratch. And it takes up a huge amount of memory and energy. But, this paper says something amazing. The researchers looked at over 1,100 models. They looked at Mistral models, vision transformers, and LLaMA models, and guess what? They found a universal subspace. Basically, no matter what the AI is learning, it tends to use the same small set of mathematical directions. It is like finding out that all the castles in the world, no matter how different they look, are built using the exact same type of bricks. Now, why does this matter to us in everyday life? Let me give you some examples. This technology can change how we use computers completely. First, let's talk about recommendation systems. You know when you are shopping on an ichino-ani site, or looking for a movie on a video site, right now. These systems are huge and heavy. They have to process so much data to guess what you like. If they use this universal subspace, they do not need to store the whole giant brain for every single task. They can just use the shared universal part, and then add a tiny little update for your specific taste. It makes the system faster and much cheaper to run. Second, think about image recognition. This is used in automatic photo classification on your phone, facial recognition to unlock your screen, or even medical image diagnosis support for doctors. Usually, a medical AI needs to be trained on thousands of X-rays. It takes a long time. With this discovery, we can take a general AI that already knows the universal subspace and just teach it the tiny difference for spotting a disease. It is like the AI is already 90% of the way there before it even starts learning. This could help doctors find patterns in medical scans much faster. And third, this is a big one. Think about autonomous driving technology. A self-driving car needs to do many things at once. It needs object recognition to see pedestrians. It needs situational judgment to know when to turn. Usually, trying to merge all these different brains into one car computer is a headache. But this paper shows that we can merge models easily, since they all share this universal structure. We can combine the pedestrian spotting brain and the steering brain into one efficient system. It makes the car smarter without needing a supercomputer in a trunk. Also, I should mention spam mail filtering, or even stock price prediction and demand forecasting. All of these rely on finding patterns. If the pattern finding part is universal, we can reuse it everywhere. Now, how does this compare to other technologies? Well, before this, you use things like standard transfer learning. That is where you take one model and try to bend it to do a new job. But sometimes, the model forgets what it learned before. This is called catastrophic forgetting. It is a scary name, right? But with the universal subspace, we can see that the core knowledge does not need to change much. We just tweak the coefficients. It is much more stable. The paper mentions that they could compress 500 vision transformer models into a single universal model. That is a memory reduction of 100 times. Imagine if your backpack was 100 times lighter. That is the kind of efficiency we are talking about. This is also great for the planet. Training big AI models creates a lot of carbon emissions because it uses so much electricity. If we can just reuse this universal subspace, we reduce the carbon footprint of AI significantly. That is a win for technology and a win for nature. So, to wrap it up, The paper Universal Subspace teaches us that AI is not as chaotic as we thought. There is a beautiful, simple order hidden and underneath all those numbers. It is like finding a secret map that everyone was using without realizing it. By using this map, we can make AI smaller, faster, and better for the environment. It is really exciting to see how this will change the apps and services we use every day. I hope you found that interesting. That is all for today's episode. This has been ichino-ani, reporting on the future of machine learning. Have a great Monday, everyone.